Okay, had some technical issue. Travis Stallock, welcome back to the live stream. Weird, it was just some networking issue on my computer, not on my Wi-Fi though, but on my computer for some reason. I'm not sure what Linux is up to right now. But there you go. Just restarted the computer and magically just fixed itself. Weird. Alright, so just going to wait a bit for people to join back in, and we're going to go to continue pretty much. Hopefully it wouldn't happen again. Hopefully it wouldn't happen again. But I guess maybe because I've left my computer like up for quite some time now, so I guess that may be one of the causes at least of the issue, but who knows. Okay, so whoever have joined back, let me know. Whoever joined back, let me know, other than Travis, of course. Right. All right. Well. Okay, so I guess I'll just continue for now, I think. Yeah, okay, let's just continue. All right, so where we were. My whole train of thoughts have hit the wall. Let's see. Oh yeah, I was thinking about No2Xnobox have said about the fact that if the protocol is not right. Oh hey, welcome back to the live stream, No2Xnobox, welcome back. Alright, so you said about the fact that I should check the name of the authentication info, because with that the parsing could change. The problem though is that the name is almost the last kind of thing, you know. It's like there's only one thing that could change depending on the parsing, which is data. Now here I have kind of a deserialized function that is kind of generic on the struct, so I can't really change the parsing much here right now. Other than that, I'd have to hard code it or make its own function kind of thing. So I think for now we're just going to ignore that issue. I think probably most people are using this MIT magic cookie anyways, so I think that's, I mean, yeah. But I'm going to just, you check host name. Oh, where is host name? Where did I check the host name though? In that while true loop. Line 99. Oh. I see what you're talking about here. So yeah, I thought you were talking about the actual parsing, not the checking. But you mean like this, pretty much, I think. And cd.mem.eql, here u8. Here we could go with MIT magic cookie, and here authentication info.name. There you go. Okay, nice. And that's pretty much it, I believe, isn't it? Let me just check that this actually works. There you go, it works. All right, so I think we have done this for now. Okay, what else? Let's see where we were. X11 connection.zig. Let's have a look into what's else. So I remember it was setup kind of thing. Okay, other than that, where is it? There you go, I think. There you go, okay. Okay, so right now we have actually written the setup, and we also have read the setup, I think. Right, isn't it? Let me check. Read setup. And this is read setup, and I guess that's right. Yeah, I guess. Yep, setup generic, read no AOF. So right now we have just checked the status if it's okay, basically, and then self.parse setup. What? Oh yeah, right now I think we have to parse the setup, right? So pretty much right now we have got the setup buffer, right? Now we have to parse it to get information out of it. Interesting. So let's find out how they're doing it. Just separate struct type. So first of all, we have a setup, protocol.setup equal undefined. Then we have an index equal parse setup type setup. Okay, so it's giving it the address to the struct, and then a buffer 0, well, the whole buffer basically as a slice, and then self.setup is equal to connection.setup.base equals setup.resource ID base. So I would guess this parse setup type function actually does the job of filling up this information. .base, mask, minimum key code, maximum key code. I wonder if we really need such information, honestly. I think we could probably just ignore it. But we'll see. Ignore the vendor for now. There you go. Plus setup.vendorlen, index plus equal vendor.len. Well, what? Buffer index up to index. What's this? I forgot what is that. Oh, I guess it's a range, isn't it? From index, maybe. Yeah. From index up to index plus setup.vendor.len. Vendorlen. Yeah, gotcha. Makes sense. Index. Oh, so parse setup type actually returns the index. Interesting. Index plus equal vendor.len. Cool. Cool. So it's kind of like a reader kind of thing. Okay. Const formats, try allocator.alloc. So it's allocating a format, setup.pixmap formats len. Error defer allocator.free formats. So it's allocating a format, setup.pixmap formats length. Cool. And then allocator.free formats. For formats, var format, protocol.format equal undefined, index plus equal parse setup type format. Buffer. Oh, I think this parse setup type is kind of like detecting, like doing something different depending on the type of the actual thing that you have passed. So basically right here I passed it a protocol.setup, so it's gonna do the parsing of that setup, and then here I passed it the format, it will do the parsing of that thing. So buffer index, again, basically from index up to the end of the buffer. And then we have f dot, okay, here we're dereferencing the, what is f? Yeah, the format. Okay, we're dereferencing the format, and then we're saying dot depth is equal to format dot depth. Okay, and then dot bits per pixel, and then scanline path. I don't think I need this information. Probably I could probably just go ahead and basically just ignore all of this stuff, I guess, isn't it? I do remember maybe I need one thing, I guess. I do not really remember. I mean, let me actually go to my GitHub repo. I did actually implemented XCB stuff before. Oh, I didn't sign in yet. Hold on a second. Well, that's gonna be wild. Okay, hold on. Let me sign in onto GitHub very quick. Where? How do you even sign in? There you go. All right, so so I'm just going to mute the microphone for a second. All right, finally done. Logged in into GitHub. There you go. Okay. No tukes, no bugs. All right, see, it's late in Europe. Another Zig X11 client you can look at is ZigX as an alternative. ZigX, let me have a look. ZigX. And by the way, I'm in Morocco, so I kind of have a similar time zone to Europe, but I actually stay up all night. So yeah, but have a good night. Thanks for tuning in. Well, let's have a look into ZigX GitHub, I guess. ZigX. Zig X11. Do you have the link to that repo thing? I couldn't really find that ZigX. Oh, I think I found it. And in fact, I think someone have linked to it before. Yeah, I think someone have linked to it before. Hold on a second. Let me go back to the Zig server. I think I've seen this before. Let's see. Yep, exactly. So yeah, someone have linked it to me before on the Zig server. Yeah, pretty much. But I couldn't really figure out a lot of what was going on. Here is kind of all over the place, you know, like there's tons of files and it seems like it's not very structured. I don't know really, but yeah, pretty much. But yeah, it could be useful later on, so yeah, I'll keep it. All right, so I thought about, so let's have a look into XCB. I've did an XCB tutorial by the way before, but it was of course in the C language. So there you go. Let me have a look. Okay, there's a lot going on here. So there you go. We have connected to XCB. Of course, the intern Atom stuff. This is not fully efficient, by the way. I do have to revisit this at some point because I wasn't aware of some how XCB does stuff exactly. Like basically, I'm much better right now understanding how XCB works. But anyway, so here I'm seeing XCB AUX get screen connection screen number. So I need, I guess, the screen number basically to get the screen. So I need to figure out first of all how I can get that screen XCB screen T thing or a similar thing basically. So yeah, pretty much, I guess. Let's figure out the rest. All right. So where we were, okay, let's go back to the source code of, where is it? Bro, what? Did I just quit that? Or is there like some other kind of, oh, there you go, okay. I don't know why I have to, let's just get this back in here. Don't need this, and don't need that. Anyway, all right, so here we go. So where we were, parse setup type format bits per pixel. Okay, and there you go, const screens finally. Okay, so this is what we really require. This stuff is, I think, is probably not very important to me, honestly, at least for my use case. I'm not willing to create like a whole X11 compliant kind of implementation. That would take forever. And there's already Xlib and XCB for that. I'm just looking into how I can basically create a window, basically. So yeah, we'll see. All right, so I think this is what's relevant to us. So the alloc screen setup.rootslen. Oh, well, setup.rootslen. Oh well, I still have to do some stuff to actually get the roots len. I need to figure out where or how they parse the roots len, and that's pretty much all I need, I think, at that point. Okay, so error for allocator.free screens for screens screen var screen protocol.screen. So index plus equal parse setup type screen buffer, the whole buffer, I think. Oh well, of course, from index. Const depth equal to try allocator.alloc depth. Alloc depth len. But what do I need the screen for though? I do not really remember exactly. Oh yeah, I need it to, when we creating the window, we're going to need the root depth and the root, isn't it? And root visual. We need these three guys, I believe. And I think that's all we need from the screen though. Yeah, pretty much. We just need the root depth, the root, and the root visual, I guess. But we'll see how that goes. So yeah. Screen to allow depth len. Okay, for depth in defined index plus equal parse setup type depth buffer index. Const visual types alloc visual type depth visual len. Okay, for every visual type, well, it needs some work, that's for sure. Var visual type protocol visual type undefined. Index plus equal parse setup type visual type buffer index. So okay, what is he? Yeah, visual type. Okay, ID bits per bit per RGB value, color map, entries, red mask, green mask, and blue mask. And then we have D, which is the depth. You get the depth and the visual types. That's kind of weird. Okay, and here S. What is S? Screen. Okay. So for the screen, there you go. We're getting the root. That's what we require. Screen.root. Cool. Screen.root. Okay, and then default color map, white pixel, black pixel, current input mask. These guys are probably not relevant for today's kind of monitors, you know, but basically back in the day you had to use these because you don't know if the what kind of colors the screen supports. And I think X11 protocol or stuff like that basically only guarantees that you'll have a white color and a black color. That's the only guarantee you have, and basically you could use that, I think. So okay, current input mask, but of course this is not the case anymore, unless if you want to run this on some sort of I don't know, embedded system with kind of an LCD that only supports black and white or whatever. But anyway, that's not our goal anyways. Unless if Vulkan would run on such devices. But anyways, current input mask, screen.current input mask, width pixel, height pixel, width millimeter, height millimeter. Okay, so you could basically take in the screen's width in millimeters, etc. That's irrelevant. Minimum installed maps, maximum installed map, root visual. Yeah, I think we need this guy. Backend store, irrelevant. Save vendors, irrelevant, I think. Root depth, possibly, I don't know, we'll see. Depth is equal to depth. Alright, cool. If index not equal to buffer.len, then return error.incorrect setup. Honestly, this is quite a lot of work, really. I think I'm just gonna copy this at this point. Self.formats equal formats, self.screens equal to screens. Format represents support pixel formats. Or I think I'm going to ignore the parsing for now. I'm just going to get the information from the server, and then whenever I need some information, I'd look up on how to parse it from the actual buffer and call it a day. We'll see. Okay. Well, I'd like to know how, like, you create a window, what you need to actually create a window. That's the real deal. So that's the read setup, parse setup. Where's the parse setup type function though? Let's see. Parse setup type. Where that is getting defined. There you go. Retrieves the wanted type from the buffer and returns its size. Wanted any type. Buffer. So it's asserting that type info type of wanted equal pointer. It's asserting that it is a pointer. And then the size equals size of type of wanted, and it's dereferenced in it. scd.mem bytes to value type of wanted, buffer 0 point size. Ooh, that's some interesting stuff right there. So basically, I think you just have to basically like define some extern structs and to simply make sure they are on the right types, etc., according to the protocol. And then here you could just use bytes to value, give it the struct type, and then you give it the relevant bytes that are required. And there you go. You're done, I think. That's interesting. That's very interesting. Okay, cool. Each screen has a root ID, which is unique and is used to create windows on the screen. Cool. Okay, what about the screen? Well, what about the window, I mean? So after that, we basically set the initial XID generator. So this is all about the connection, basically. Interesting. With another tab or window. Okay, cool. Let's go to X11. And what about the window now? Title, values, property mode, window class. Creates a new window on the given screen using the settings set by options. For now, creates a window with a black background. Try con.genxid connection, and it needs the screen. There you go, and it needs the options. Now we can know what stuff it needs. There you go. Mask, temp, and 4 options value. So where the screen is being used here, that's the real deal. Okay, so you actually need the root, and we need the root visual. That seems like all we need to actually create a window. Interestingly. Let me have a look onto all of the references of a screen in here, just to make sure. Yep, pretty much. All we need is a root and root visual. We gotta figure out how to parse those. That's all we really need. We don't require all that stuff. So let's find out how to do that. Root and root visual. Root visual. Okay, let's go back to the connection. Root and root visual. Oops. Connection.zig. Let's find out where it's actually getting the root stuff. Incognito hacks. Welcome to the live stream. Where's your experience with Zig memory management, if you don't mind me asking? With Zig memory management, like in what aspect? In what aspect? Zig memory management. Root visual. There you go. Screen. Depth. Okay. Roots len. I honestly think I'm just going to copy this for now. Let us not waste a lot of time. Although it would have been nice if we could just basically take only the stuff that we really need. But anyway, allocating and deallocating stuff. I'm a Python program trying to learn Zig, and that has been confusing. I came from a background of, I guess, Rust and C. Pretty much a fan of C language. And let me tell you, Zig memory management is like the best you can get. Honestly. For example, and also error handling. I mean, well, there is... so there is Rust, there is C, C++, and a lot of other languages, but basically these languages are kind of low level, so you have to manage memory yourself. Now the problem with let's say for example C++ and Rust that I find, for example, and even C, but let's just go step by step. For example, to actually deallocate memory, like to make sure you're deallocating memory rightly, even when an error happens, for example, or whatever, to do proper error handling and proper memory management, you have to use classes. So every resource, you have to basically wrap it in a class, in a new class or whatever, and you have to make sure that the constructor kind of like allocates stuff, and then the destructor deallocates stuff. But then you basically are forced to go ahead and create a class for every little object, for everything, which takes tons of times, because if you don't, then when an exception happens, everything goes crazy. Like, you do not really do anything. You cannot really do anything at that point. For Rust, kind of a similar thing. You have to kind of implement the drop trait on the struct to do that too. But in Zig, you know, you just, when you allocate stuff, let me see if, where I'm allocating something. Alloc. Okay, so for example here, I'm allocating this guy right here. I just, after the expression, like after the line where I'm allocating stuff, I just, after that I say defer allocator.free or error defer, depending on the context. And it just does that for me whenever the function, like when we return from the function through an error or through whatever happens. When you return from the function, you are guaranteed that you will actually free that memory without having to actually create a class, you know, and making sure that the structure deallocates memory, etc., etc. So that's pretty much it. Like, to just answer your question directly, I think Zig is pretty much the best, in my opinion, of course, in my opinion, the best when it comes to proper error handling and proper memory management. And that's why I love Zig. And also the comp time stuff, like compile, comp time, Zig stuff is very useful and interesting, especially for serializing and deserializing, like you see here. So for example, instead of actually encoding, like hard coding the serialization and deserialization, I could just make something like this deserialize function right here, which just goes ahead, loops through all the fields of the struct that I gave it, and just automatically does that for me, basically. It's just very useful. So that's pretty much it. Hopefully that answers your question. So anyway, let's see what we got so far. What we got. Travis Tallock. In my experience, memory management is the most difficult aspect to master coming from higher level languages. Yeah, it can be very frustrating sometimes. But honestly, Zig so far I think is probably the easiest and the most correct way of managing memory, etc. But anyway, we'll see. Alright, so what else right now? So as I said, we need the root and depth root, or what was it? Oh my god, I forgot again. Window.zig. Root. There you go. We read the root and the root visual. Alright, let's just try to go through this. Parse setup, or I could just copy it over and not waste time on it for now. Format represents support pixel formats. This is the whole function. Okay. Later on we could maybe try to change it to fit our needs. But Zig does provide some very helpful tools which makes it easier to see. Yeah, easier and also much more correct. Like defer and error defer. I just cannot understand like why defer and error defer doesn't exist yet on the C language and the C++ language, etc. It's just so useful. It's such a simple feature, but it just makes all the difference pretty much. But yeah, so here we need the setup struct, and we also need the format and the screen, isn't it? So let me see the protocol dot. Oh, we also need the depth and the visual type. Okay, well that's a lot. That's a lot. Root and root visual. Okay, protocol dot. Cool, so let's actually get all those stuff. So we need the format, we need the depth, and we need the visual type and the screen. And also we need this function, parse setup type. And let's just copy those over. This is becoming spaghetti code, but anyway. Alright. I think that's probably it. Setup. What about setup? Do I have setup yet? MYD, welcome to the live stream. Wa alaikum assalam wa rahmatullah. Setup. Let's see. Setup. I don't think I got the setup yet, isn't it? Const setup equal to. Yep, I need to actually also copy the setup here. So struct. Well, there you go. I actually got it directly. Let's go. Okay, it seems to be compiling, but we have to of course try it now. Let's see. So dot okay, where is that thing? Alright, so if self.status equal okay in read setup, reading the setup. So we got the setup buffer, right? There you go. So now basically when we got the OK, which we have here through the assert, we could just simply go ahead and try parse setup buffer. Connection. Interesting. Where it's using that self.stream.handle, self.gpa, self.setup, self.formats, and self.screens. Alright, well, I kind of had to honestly use the connection struct from the start. It's becoming really weird. But let's see. Allocator. Well, I guess let's just do it, okay? Allocator is equal to scd.mem.allocator, I guess. And then what's next? We also need the setup. Connection.setup. Setup. No, I think setup basically. Yeah, probably. Isn't it? And now we got some weird problem. Setup in the find parse setup type. Honestly, I kind of lost it at this point. So basically, I should have honestly used the connection struct just like they're doing. It's crazier than I thought. Anyway, base setup.resource ID base. Yeah, kind of lost it at this point. Well, I guess let me try to maybe just, let's see. Weird. You know what? Go back. This is getting out of hand. Okay, we're back into this guy right here. Yep. Okay, I think we were good until this point. Alright, well, I guess I just gotta do it myself anyway. Read no AOF assert. Okay, so right now we have to actually do that. Let's see, parse setup. Okay, let's go step by step here. So here we got setup and index, parse setup type. Setup in the find. Okay, let's get the setup. Where is the setup? There you go. Const setup. Let's go. And we also need that parse setup type function. Parse setup type. Where is it? Okay. There you go. Kind of got it there. There you go. Fn parse setup type. Let's go. Alright. Size of type of bytes to value. Given a pointer to an array of bytes, returns the value of the specified type backed by a copy of those bytes. Hold on a second. All right, back. Okay. So we got that out of the way. Now what's next? Okay. Buffer is the setup buffer. Index equal to parse setup type setup buffer. Okay, and then what's next? Let's actually see if this actually works. There you go. Seems to be working. Okay. Now self.setup is equal to connection.setup. Well, that's basically const setup is equal to setup, I believe. Yep. Oh. What? Well, in fact, that's kind of different. I mean, that's protocol.setup and this is connection.setup. What? Interesting. Protocol setup. Well, honestly, this is getting out of hand. I should probably refactor this off camera and I'll see how it goes, really. But in fact, this is going wild. X11. Refactor. I mean, it's the same exact thing. Why have a connection.setup and then a protocol.setup, isn't it? Base? I mean, yeah, exactly. Like, why have two things? That's the first one, okay. Go back to the other one. Really? Where's setup here? Const setup equals, okay. Well, there you go. No, these are both connection. Oh my. Remove that one and let's go back to protocol. Oh, well, in fact, it's much bigger. There is maximum request length, routes length, all of this stuff. Interesting. Oh well, I think I gotta refactor this off camera at this point, and then maybe we could continue later on the next stream. So yeah, pretty much I think that was it for this live stream. But stay tuned. I think I'm probably going to restart another live stream, but we're going to be probably starting out again on Vulkan. We'll see how it goes. But yeah, I think that was it for this live stream, and see you in the next one. Goodbye, everyone.